Okay, so we look at a question on stoichiometry, and the question that we have reads: urea and ammonium nitrate are two nitrogenous fertilizers commonly used by farmers. From that, we need to answer questions A, B, C, as well as D. Okay, so question A says we need to calculate the percentage composition of nitrogen in urea. Okay, so we'll talk about the percentage composition. Okay, the percentage composition of an element in a compound in this case. So we are going to say the formula that you are using is more like okay, let's say we have just divide that. Okay, so the the formula that you are going to use for calculating percentage composition is that we're going to say percentage composition. I'll just say percentage composition in this case. Composition is equals to the the mass of the element. Okay, mass of element of an individual element in this case, element divided by mass of the compound, in this case using the molar mass, multiplied by what, 100%. Okay, so what do we do in this case? This is the formula that you have been given. This is the chemical formula that you have been given for what? For urea, which is uh, C, which is for carbon, oxygen, open bracket, nitrogen, hydrogen, like that, a 2 here and a 2 like that. Okay, so from the periodic table that we have, the molar mass for carbon is equals to 12. The molar mass for oxygen is equals to 16. The molar mass for nitrogen is equals to what? 14. Then the molar mass for hydrogen is equals to what? Is equals to 1. Okay, is equals to 1 like that. So here on top, or on the numerator here, on the mass of the element, we are going to put the mass of what? The mass of nitrogen that we are finding. So it's just basically 14 multiplied by what? By 2. Where is the 2 coming from? It's the 2 that is outside here. Okay, so we say divide by now. Okay, so the mass of individual elements of the compound, we add them together and we find the sum of that. So for carbon, we know it's what? It's a 12, plus for oxygen it's a 16, plus for nitrogen itself, again we have a 14 here by 2, giving us what? A 28, plus then for hydrogen we have a 2 here multiplied by 2, giving us what? A 4. We are multiplied by what? A 100. Okay, so what you're going to have is a 28 divide by, so here what we are saying is a 12 plus 16 plus 28 plus 4, giving us what? 60 multiplied by what? A 100%. So what you're going to have in this case is we are saying 28 divided by 60 multiplied by 100, giving us 46.7 46.7%. But of course this value was something like 46.66666, then 7 at last, but we just round off to one decimal place, which is 46.7%. So that's the percentage composition of nitrogen in what? In urea. Alright, so it's very important that we make use of the periodic table that we are given. Alright, so the second question says explain the importance of nitrogenous fertilizers in nitrogenous fertilizers on in the environment. Okay, or in agriculture in this case. Okay, so what we need to understand is that the plants needs they need proteins, and those proteins we get them from amino acids, and from those amino acids we need to have nitrogen. So without us having nitrogen, or in this case that are described as nitrogenous fertilizers, we're not going to have the proteins that we that we need. And us lacking the proteins that we need, there's going to be a negative growth in terms of the what, in terms of the plant. So one point is that the plants, they need proteins, and proteins, we get them from amino acids, and from those amino acids, that's where we need that's where we have the what, the nitrogens that we need. Okay. So C says, describe the effect of using nitrogenous fertilizers on the environment. So it's also very important to understand that whatever that we do, whatever that we use on plants, in the environment, or anywhere, it has a positive side of it and a negative side of it. So we also need to understand that the the excess use of the excess use of the excess use of nitrogen on the environment, we are what there is a point whereby if you have excess nitrogen, okay, if you have excess nitrogen, what the bacteria in the soil, they're going to get that nitrogen and convert it into a nitrate. Okay, a nitrate. Okay, and that is a water soluble, uh, it's water soluble. Okay, water soluble nitrate. So when this is converted from nitrogen by bacteria, it goes out of the soil, and when it rains, all of this is going to perhaps maybe go into rivers or lakes, and that is going to cause a lot of pollution, in terms, maybe that would be the water that people are drinking, or we also know to say in that same water, that's where we find fish, so that is going to cause pollution. So you find that if there's excess nitrogen, the bacteria are going to convert that nitrogen to nitrate, which is water soluble, and is going to come out of the soil, and it will be swept off, and it might go into rivers or lakes, which at the end of the day is pollution. All right. So part D says, apart from nitrogen, name an element needed for one, root development, B, seed formation. Okay, so for root development, in addition to nitrogen, but of course, as you answer the question, you don't need to write down the nitrogen, as we say apart from. So we can name potassium as well as phosphorus for root development. Then for seed formation, it includes with nitrogen itself, but you don't need to name it because they've said apart from. We have also potassium itself. We have phosphorus as well as sulfur. Okay, so that's how you go about answering such a question. And don't forget to like, don't forget to subscribe and share the link to your friends, and please leave the don't forget to leave comments in the comment section if you have any queries, and if you have any video on any topic that you would want us to make for you, feel free to leave all those in the comment section. And thank you very much for watching, and have a nice day.